Hello everyone, my name is Tobias Blanke and together with my colleague Professor Aybüke Özgün, I will chair today's session. Before we go to our main speaker, I hand over the word to Claire Stefrede, my colleague, who will briefly introduce the ideas behind Humane AI.
Thank you very much, Tobias, and welcome all to this inaugural Humane Conversation event, part of the Humane AI research priority area of the University of Amsterdam. We're very happy to have this research priority area that really cuts across so many different faculties and disciplines. And I will be posting the link to the new website and all kudos to Gianna and our web designer for getting that done, so that you can familiarize yourselves with also all the current ongoing projects in Humane AI. Humane AI is also chaired by no less than 4 people. So in addition to Tobias Blanke, who is chairing today's sessions, also Natalie Hellberger and Sonja Smets, and I am the chair of the research priority area for this year. We're very delighted to be launching this Humane Conversations format as part of the research priority area, and then I hand it back already to Tobias. Take it away, Tobias.
Great, thank you very much. So it is then my great pleasure to introduce to you Professor Max Welling today. I don't think he needs a very long introduction. In fact, when I joined Amsterdam about a year ago, I was told that Max is the person to go to here to learn about AI and machine learning. Max is a physicist by training, and we will hopefully come back to this a little bit later, how this links into his current work. He is currently research chair in machine learning at the University of Amsterdam and has co-founded Cypher, a university spin-off. And I think Cypher was then acquired by Qualcomm, where he's now VP Technologies in the Netherlands. Max has served on the editorial board of some of the highest profile computer science journals and conferences in AI, including being the general chair of NeurIPS, as I think it's called now. He has won, of course, numerous grants, and I can't really count them down now here, but what I find particularly exciting is that he worked with Geoffrey Hinton on things like Boltzmann machines long before any of us was actually aware that we are at the cusp of a new AI revolution. Max will give us an exciting view on where we are with machine learning and where we are going. But before we do that, quickly some housekeeping. So the 2 chairs of this meeting are myself and Professor Özgün. We will be able to first ask some questions after Max's talk before we then open up to the whole audience. In order to organize this in the typical Zoom way, we ask you to type in the questions directly into the chat box, or even better, type in your name if you want to ask the question in person. We will then call you simply in order. Thank you very much. And Max, I hand over to you.
Thank you very much, Tobias, for the kind introduction and for inviting me here. In what I now understand is the first session of this. So I was asked to give a bit of an overview of where I think AI and machine learning is going. I'm happy to do that. So my expertise is mostly in machine learning, which is a subspecialty within AI. AI is much broader than what I study. And machine learning, of course, deals with sort of self-learning systems or systems that look at data and improve themselves over time. Now, what are the exciting directions in which this field is moving? So I want to separate that question into 3 subparts. The first part is compute, the second part is data, and the third part is algorithms. And these are, in fact, and indeed, the sort of underlying components of modern AI. And that has sort of been at the basis of the sort of, well, if you want, revolution or acceleration or hype or whatever you want to call this thing that's happening right now. So let's first turn to compute. So certainly the AI sort of started to accelerate, the applications of AI started to accelerate when people figured out that they could have built their own little supercomputer, which was a GPU, which was already in their computer often because it's graphics card hardware. And from then on, what we have seen in the industry, and so since I'm working at Qualcomm, I can sort of see it firsthand. What we've seen in the industry is that and especially NVIDIA as being the major player in this, and Qualcomm more on the sort of mobile side, that these graphics cards and these GPUs, they were specialized for sort of deep learning computations. And sort of, we call this ASICs, that's specialized hardware, especially for doing these deep learning or machine learning computations. Now, where is this going? So there's one very interesting, you know, we could all be very impressed with, you know, how this compute is going and how powerful it is, and of course it is, but still our brain is 100,000 times more energy efficient, which I find very telling and interesting statistic. So we can eat a sort of a sandwich and we drive from Limburg all the way up to Groningen, and that's okay. Where if you use a self-driving car, you would need 500 whatever watt, or you know, to do that. So I think we will turn again back to brains and study how are we going to do this AI computation much more power efficient. And so this is simply because, you know, if you have a phone, it will burn out of your pocket if it gets too hot. And if you're a big company and you want to use AI, and it's basically your energy bill, which is too high at some point, and it doesn't become sort of you know, useful anymore for you to use that particular piece of AI. So that's sort of neuro-inspired hardware. But there's also other things going to happen, which is, for instance, quantum computation. Of course, quantum neural nets are on the verge of sort of becoming very powerful. And optical computation is another one which is very promising. So we're going to see a lot of development in compute, and this will drive the field of AI further. The next topic is data. So in the field of data, of course, we are all, you know, it is basically the gasoline of AI. Without data, you can't really do machine learning very much. Privacy laws in Europe, which is a good thing, but it also means that it's hard to get your hands on data, on large data sets. And as we have seen in machine learning, and especially deep learning, more data just gives bigger and better models. And this is a sort of maybe ironic, but if you look at GPT-3, is like huge amounts of data go into it, and you get very, very convincing. You better models, at least for these applications. And so how are we going to handle this if the data is also behind bars, right? In sort of locked up in boxes that we can't have access to. So fortunately, I think there is a very good paradigm, which is federated learning. And in federated learning, the data resides in sort of safe, you know, safes, in some sense, data safes. And instead of moving all that data to the cloud, the algorithm moves to the data and knocks on the door and says, I would like a model update. And then the particular database will basically figure out, okay, how much sensitivity is there in this request? Let me noise up the data to a sufficient amount, or aggregate it in a way so that there's no sensitive information revealed about the people that are in this database. The update is provided, maybe a payment happens, and you know, the algorithm keeps on learning. I think this is a very interesting paradigm that could break this problem of not having access to data. It is a big investment, but maybe Europe can sort of excel in this kinds of things, where if we now invest in it, we may have a paradigm that is that can actually accelerate AI applications further. And then the third topic is algorithms themselves. Of course, deep learning is the one that in around 2010 sort of caused sort of the acceleration to happen. Yet we also have to be realistic and say that, you know, currently these algorithms are very good at doing very particular things, like language models are very good, speech recognition is very good, image analysis, video analysis. So all these topics where you just have a very, so we have sort of a high dimensional signal, and you're sort of sampling this at a high frequency, and you're trying to make sense of that very raw data. At the same time, these applications are often extremely limited. So you train it on one particular topic, you have a lot of data for that one particular domain, And then you can do very well in this particular application, but as you shift it slightly away from the topic, right? You shifted the the people on which you trained it, or you shifted the input density, then everything starts to break down dramatically. So humans again are very good at this. So you train them on one thing with maybe a couple of data points. We absorb this information, our ocean of background knowledge, right? In our common sense and our understanding of the world, and we can generalize to completely new situations, which is extremely powerful. This flexibility that we have, we call this AGI, so artificial general intelligence, and some people are trying to sort of get achieve that in computers as well. So you can think about what is the actual what are the things that we are still missing currently in our frameworks, and one of them is perhaps we can imagine things, we can build counterfactual worlds that never happened and will never happen. I can ask you to imagine a blue elephant on a unicycle on the moon. You have no trouble doing it. You'll see, obviously, but you can imagine it. And this power of imagination is amazing in my feeling. And there's also, of course, a knowledge about the world, common sense of how the world operates, how it works, what are the physical laws, what is causality. All of these things are currently not in our models. And integrating that in our models, this generative process of how the world works, I think is a really a shortcoming that we need to fix, and that will sort of maybe lift us to the next level. And of course, finally, in order to have uptake of AI, we need to build trust. And there's, in my view, there's two different kinds of AI. One that needs oversight, ethical frameworks. It needs to be fair. That there's everything that has to do with humans and decisions about humans and impact on society and all these kind of things. We really need to start, taking better care of that. There's also a whole bunch of algorithms or applications where this is not all that necessary. Let's say if Qualcomm designs a new algorithm to design a new chip, we have no idea how it does it, but yet it produces this fantastic chip. You can check that it is a great chip. Fine, right? It doesn't have to be fair. It doesn't have to be responsible. It just produces the chip for you. And to some degree, actually, it's also interesting that even in the medical field, this is already a bit true. We train dogs to detect COVID. They bark 3 times when they detect somebody COVID. No idea how they do it, yet they figure it out. You can, of course, argue, well, maybe you have to be worried about, does it do it equally well for one type of person? Maybe for women, it does it much better than for men. Is this a problem? Still, if we have the dog or an artificial dog that would bark 3 times for a large subclass of people if they have cancer, and then you can actually check that they have cancer, I think they will be used, right? Anyway, thinking about these, I'm sure this is the topic of your organization, is very aligned with your organization, is of course also a very important thing that we need to think about in the future. And I'll end there.
Thank you. That was very interesting. I hand over to Aybüke.
Yeah, thank you very much for this very concise and informative introduction to machine learning and artificial intelligence. So maybe we can just start with start with your research a little bit more deep, and then maybe you can tell us a bit more about which part of your research excites you the most, or also maybe in view of some applications, so on and so forth. Can you tell us a bit more about this?
Yeah, so my research is mostly on the fundamentals of machine learning. So very much on, let's say, improving deep neural networks, making them, incorporating symmetries of the world in these networks so that they are reflected in the network. So yeah, if you look at an image of a medical image of a nodule or a pathological slide of tissue, if you rotate the tissue, it's still a fine image that you could have seen in the real world. Or if you're a drone and you're flying over the world, if the drone turns around, it's just still a fine image, right? The fact that whatever your application is really doesn't matter about how you're oriented. For instance, if you want to detect whether there is cancer in a pathology in a piece of tissue, then it doesn't matter how it's oriented. The answer yes or no should not depend on that, right? And incorporating these symmetries in your neural networks is one of the things I've been working on with all sort of wonderful students and collaborators. So I think most of my applications are in the medical domain, at least the more serious ones, I would say. So we've also applied some of this technology. So I've been working on sort of a framework where you can combine sort of more classical signal processing algorithms that are not necessarily machine learned, or classical sort of optimization algorithms, and combine that with neural components. And I call this neural augmentation. So we have a classical algorithm, which could be very interpretable, that algorithm, or it could, so you know what you have there, but then the sort of the subtleties are being corrected by the neural algorithm. And we've applied that to, for instance, fast MRI. So fast MRI is a topic where you want to reconstruct an MRI image from a limited set of Fourier observations. The observations are in the Fourier domain. And you want to look at a limited set of those, but still get an equally sort of high resolution and high quality reconstruction of that image of the body. And we've applied this particular technology. We've taken, basically, we've used the fact that we know precisely how the observation channel works, which is, this is how the physics of the MRI machine works. We've incorporated it into a neural network, and then we've participated in a competition. And in fact, in one of the tracks, we won using this particular sort of framework. And we are now building on that by sort of also thinking about, can we have the algorithm actively decide what to sense? So we call this active sensing. So this means that you can choose between a whole bunch of Fourier components with maybe the low frequencies or the high frequencies. And it sort of reasons about, okay, this is my current reconstruction. Now let me do this observation. And then you add the sort of observation, you do the reconstruction, and then you think, okay, maybe I'm missing this. And then you do this observation. Right? And so you find a path through sort of Fourier space and doing all these observations. And sort of we have a recent paper based on that with a student and a colleague. So I guess that's one side. There's a whole bunch of stuff that we do also on the Qualcomm side. Maybe we talk about it more, but yeah. So I guess the most exciting thing, and maybe we'll talk about it more later, for me right now is to combine quantum mechanics and deep learning and machine learning.
Thanks. Tobias, should I just continue with my next question? Okay, perfect. So, well, as Tobias mentioned in the beginning, you actually have a physics background. You did your PhD in theoretical physics. So I was just wondering, so what made you move from theoretical physics to machine learning? And like, how does your physics background, if at all, help with your research and job in machine learning?
Yeah, so at that point in time, I was working on something that I felt was an intellectual challenge, but not necessarily have a lot of impact. It was two-dimensional quantum gravity. And so I could see myself writing papers. I see Tobias do this. I could see myself writing papers on that for a long time, but then I was worried, what would I actually have achieved, right? I would not have written or contributed, an algorithm which would be able to, get people faster out of an MRI machine and potentially even have something where you could radiate and image all at the same time. Impact in society I was looking for, and that's why I decided to leave physics and go into a sort of a young. Now I should say that things have started to come around. So this whole business about sort of incorporating symmetries in neural networks is basically I'm to work on this particular topic, which I found very exciting. And nowadays, the next step that we then put is say, okay, let's think about quantum mechanics. So can we define neural networks that not only would run on a quantum computer, but would also be different, so that they would especially use the features of a quantum computer to be stronger than a normal neural net. So we've just recently submitted a paper on that. And our latest breakthrough is basically doing quantum field theory in neural nets. So we have discovered Hintons. Hinton, you know, Hinton is this guy, I think somebody already mentioned it, is Jeff Hinton. I worked a while with him, and it turned out the fact that your name ends on, like a boson or a fermion, was too good to be true. So we needed to discover Hintons. So we set out to do that. And, you know, to our surprise, we found a very beautiful theory of quantum field theory to describe neural nets. So that's not published at all, but we are working on that with my collaborator, Roberto Bondestan at Qualcomm. So that's, yeah, so the impact on physics, let's say, has been very large. And it's these days I feel more like a half physicist and a half machine learner, I would say. So.
Yeah. Okay, so yeah, I think I'll ask one more question and then I'll leave the stage to Tobias. So this is a bit of a different question. It's more on the conceptual side, and it's about transparency and its applications for algorithmic accountability. So in general, like transparency as, like, roughly speaking, being able to see how a system works, or as being able to open the black box of this machine learning algorithms, is often seen as key to algorithmic accountability. So the idea being that if we see how a system works, we can understand how it works, and we can know how to govern the algorithm. But they're also opposing views. So some people think that transparency is an ideal that we cannot reach, or even if we can reach, it's not adequate for algorithmic accountability. So I would like to hear your opinions on this issue, whether do you think that transparency is feasible, and if it's feasible, it's even adequate to govern algorithms, or if not, what else we might need for algorithmic accountability?
Yes, that's of course a great question. So transparency for me has two aspects. The first aspect is that when you develop an algorithm, that the code for that algorithm is right. So especially if you have an algorithm that decides on, let's say, whether humans can be released, early from prison, I think it's very undesirable that you use an algorithm and nobody, that's a company property and nobody knows what it's doing. Of course, that's the level of transparency that we should never have. Now, the other, I think what you were pointing more towards is whether we can understand the algorithm, what it's actually doing under the hood, right? So my answer is, again, there's a very broad spectrum of applications. I think some people tend to forget that, right? So there is a lot of applications where really this transparency is not needed. I mean, somebody who tries to decide the stock market, if it goes up, if it predicts it's up and it's going up and it's earning money, no problem, right? So, and there's many of these applications. Basically, in Qualcomm, almost all problems that we work on don't have that, we don't care too much of how they work, precisely underneath, all the things that are happening, as long as they do what they need to do, and we can verify that they do the right thing. But that's different for algorithms that have a direct impact on people. And of course, I think, there is very subtle. And so the question is, I think the key is that we need a way to certify, and that's very difficult. So we need to find ways to certify algorithms, even though they might be complex for us to understand. I mean, if we're really honest, do you understand the television, right? I don't know, or a computer, no idea how it really works, right? And but still we use it, and we're happy to use it. So we don't need to understand everything in all its details, but we need to certify it. For instance, if I go in an airplane, I want to make sure it doesn't fall out of the sky. So somehow I need some kind of certification that that's not happening, or the probability of that happening is extremely low. So I think that's still fine for complex systems. I mean, we can test them like crazy on, try to prove that we cover all corner cases and we test them. I think we can manage to do that to some degree. We are already doing that. An airplane is a very complex system. However, when a system is self-learning, now it gets really troublesome, right? Because if it's self-learning, it could learn itself into a corner where it wasn't tested. And now I think we have to be extremely careful. So deciding whether you will get a loan for a bank, we may not want, we just have to sort of put a certain limit on the complexity of such algorithms. We just say, okay, this is too important for us to make sure we don't make the wrong decisions. So let's make this algorithm extremely transparent in the sense of simple and understandable, explainable in some sense, right? And so I think we need some kind of classification of application areas where for this you can go, this is okay, you can certify and it's fine. And for this, you have to be able to completely explain how you came to that particular decision. And sometimes it's counterintuitive, as I said, for the dog, the barking dog, right? Or the, if I have some kind of magic electronic nose that figures out whether somebody is sick, I think it's still, we should still consider it, even though we may not know how it works, as long as we can then later, verify that it actually did something useful.
Yeah, thank you. I think Tobias is going to continue now.
Thank you both. That is very interesting. So I'm also very happy because I already have now 3 questions. Can I remind everyone that you please either note your name or type in the question directly in the chat box. We will call you after we finish our initial set of questions. And my next question really basically just continues with what we just discussed. Of course, this network is called Humane AI, and we, of course, who are behind this network would be very interested to hear from you, Max, what you think would be a good contribution that Humane AI could do. And is this actually an interesting topic also for people who work in the narrower field of machine learning applications?
Yeah, so in fact, I am in a consortium called Hybrid AI, or Hybrid Intelligence, which is a Zwaartekracht sort of grant, where I think this is very aligned with Humane AI, except that maybe we come more at it from the technical side, and this group comes more at it from the social side or the humanities side. And I read your blog post, you sent it, and I can only say that I agree with that assessment, that in fact there is a very important role for humanities to think about the impact of AI in our society. This is something that we are not naturally good at, and we shouldn't put on those shoes ourselves. I've often been asked, when you design a new algorithm, are you thinking a lot about, all the negative impacts that that algorithm will have? Which is to me a bit similar to asking from a mathematician, if you prove your new theorem, are you thinking about maybe that it will make an atom bomb more efficient or something like this, right? It's so far remote from what you're doing that this is not something that we think about naturally. I mean, the honest answer is no, right? I'm not thinking about when I improve the efficiency of my neural net, I'm not thinking about what the long-term impact of that is. And so having a discussion with people who do know more about the impact of these types of technology on society is very valuable. In fact, I recently saw The Social Dilemma, which I think is a very beautiful movie about the impact that technology has on our democracy. And it in some sense it wasn't an eye-opener. Of course, I knew all that was being said there, but having it said so powerfully in such a short amount of time sort of was, like, whoa, okay, this is, we should be super careful about it. And I think it is much more natural that humanities takes this role than that we take this role, and that we work with the humanities to, to figure these things out.
Great, we like to hear that. Thank you very much.
You can pay me later.
And then I have
it's fine.
Maybe we can do a little Netflix party where we all watch The Social Dilemma together.
Sure.
So I have one more final question, which is of course also quite actual in the sense that the University of Amsterdam has just gone through some difficult collaboration with outside companies, and we know that you work with Qualcomm, I think you pronounce this.
Yeah.
I don't actually know. Yeah. So how do you feel about the relationship between like AI research within a university and within a company? So
Yeah. So for me, it has been an extremely positive experience. And the reason is that I see all sorts of new problems that I don't see at the university. I mean, I haven't thought, I give you a good example. I haven't thought about the close interaction between computing and machine learning until I joined a company that has computing at its core, right? So I was always thought I design an algorithm, I throw it at a computer, and it just does what I do in infinite precision. Well, okay, 32 floating point, but that's basically infinite precision. I never really worried about that, right? Now, at a company, you figure out, well, okay, but that's not how it works, right? I mean, it takes too much energy, and so we should really go to 8-bit, integer precision. But then how do you do, learning when you only have so little sort of accuracy in your computations? Well, it turns out that neural networks are very robust to this kind of noise in your computations, like our brains are also quite robust to this kind of noise. And so you get to all sorts of new and interesting questions that I never asked myself before. So I'm in the fortunate position that at Qualcomm, we have a lab, which is called Qualcomm AI Research, which is doing basically fundamental research. I do my quantum field theory research at Qualcomm, right? So it's like, I can do very fundamental stuff there, and in an environment where there is, these real applications potentially of some of the things that we think about. So for me, this is very intriguing. I thought you were going to ask about possibly the ethical parts of it, which I'm very happy to discuss. So if you want to ask that question, please go ahead.
I think so. That is, of course, because we all just went through the Huawei story, but I guess Qualcomm is not the same as Huawei. But of course, that would be interesting to us. Yeah.
Yeah. So this is clearly a difficult question, and it's not so easy for us as well. So we had, sessions with other people discussing precisely what are the guidelines and how would you handle these kinds of things. And there's a complex answer that, for instance, Frank van Harmelen would be better in answering than I am for the particular collaboration with Huawei. For the collaboration with Qualcomm, I don't have, okay. So I guess one of the doubts that you can have, which you often see in medical research, is that the company has a particular desired outcome that is not aligned with sometimes the truth, right? So in other words, you invent a new medicine, a new drug, you want the drug to work, so you go to a professor and say, prove for me that this drug works. And then the professor finds the drug doesn't work, and you take the professor to a nice and fancy dinner, and maybe then it works, right? So this kinds of influence is real. So you have to be very careful that the objectives of the company and you as an academic are aligned. It turns out that in Qualcomm, this is perfectly aligned, or for the Qualcomm sponsored research lab is almost perfectly aligned in the sense that they want the best algorithm, we want the best algorithm, we both want to have it published, and there is this additional IP will go to the company instead of the university, but that's kind of the monetary exchange you make. You get an investment of like 4 million or whatever, and what comes back is the IP goes to the company. And so you can think, universities are not great at monetizing IP. They have proven so in the past. There's nothing good that came out of it. It only cost money to get this, patent things. Companies are doing that much more efficiently. So for me, this is a perfectly fine and reasonable exchange. So I guess the only point of stress with some companies is that because of the IP situation, the collaborations are sometimes more complicated. So a student wants to collaborate with whoever they want to collaborate. Sometimes this is a process that takes time and effort to achieve, which is maybe slightly suboptimal, but in my opinion, it's worth the the effort. what we get back is a very vibrant AI ecosystem in the region where there's our work goes into, you know, companies and society, and people will flow through these companies and start their own startups and interact with organizations like ILLC that I'm also co-founding. I believe in strong AI ecosystems in the region, and I think this will certainly contribute. I mean, the fact that we have a lab, you know, almost 50 or to 60 people from thing that Qualcomm decides to put this particular research in Amsterdam, I think is a very, you know, good contribution to our ecosystem. So the Huawei deal is of course much more complicated because there the you know, the particular sort of the ethical considerations are different than for Qualcomm, I would say. But I think it's better to talk to Frank van Harmelen about the considerations that were made for that particular lab.
A lot of follow-on questions, but I don't want to just monopolize the discussion here. So I would like to now move on to the first question, which brings us back to more like neural networks. And I think that's Robert.
I can't hear you, Robert, you're muted.
Do you hear me now?
Yes.
Okay, good. Yeah, so I was interested to hearing your talk. You say that, okay, there are limitations of neural networks, right? In particular, it cannot account for imagination and basically counterfactual questions or counterfactuals. Now, I come from linguistics and philosophy, very interested in counterfactuals. And well, we're interested therefore also in causation, right? Using causal models to account for counterfactuals. Now, as you probably know, Judea Pearl, who's the big man against, who's the big man from causal models, he's not very positive about neural networks, right? So he suggests that, well, we need to do something else. Now, you are much more positive. You say, yeah, there are limitations of neural networks. It cannot account for counterfactual imagination. You have to integrate causality into neural networks. So could you say a little bit about how you think that should be done?
Yeah.
And a follow-up question is, so you have a physics background. Is there anything to gain from physics of how to integrate that or not?
I see. So the first thing I want to say is that the field has a little polarized, which I think is a pity. But even if you probe Judea Pearl on his opinion, which I sometimes do on Twitter, he does also retreat to a position which is more in the middle, I think. And think most reasonable people are somewhere in the spectrum in the middle and not completely on the outer side. I think that's not a very reasonable position to hold. And I can sort of illustrate that whether you like it or not, deep learning models are very good at what they do. And there's no doubt about it. I mean, and companies like Google and Qualcomm, where people make decisions based on money, they use it all over the place. And that's not for nothing. They make money on it, right? And so models like language models like GPT-3, you can say all sorts of things about it, like, oh, it doesn't really understand what they're saying, all these kinds of things. But it's producing coherent text for pages and pages, and that's maybe 5 years ago would be unimaginable. So in my opinion, of course, when the bar shifts, people will keep, saying things like it's not impressive and we should do other things, all these. But you can, if you're really honest about it, you have to be impressed with the things that deep learning is achieving. On the other hand, it is also lacking in many ways, and there's also many people who are, happy to admit that it's not the silver bullet which will solve everything. There's things that humans do far better. And so then the question becomes, what is the key? What is the key to solving that? Now, and sort of, I think this was your question. So for me, it feels like we need to. I mean, even in our human brain, these two processes are separated. And if you look at Daniel Kahneman's book, Fast and Slow Thinking, you can sort of see some of that there. There is very fast bottom-up recognition, which is done by these deep neural network-like structures in our brain. They go unconscious, they go very quick, and they immediately make me recognize everything that's happening around me. yet it's not reasoning, right? It's not something that is over time and full of effort and consciousness in order to produce some kind of reasoning. And that seems part of our brain. Now, I think the key to it is being able to, let me predict the future in an abstract sense. So in other words, I don't think we will ever have to predict future scenarios from at a pixel level. That seems way too much effort and energy to do that. But we need to be able to predict, to unroll our futures, depending on sort of certain actions that we take in those futures, at a very abstract sort of concept level, right? So for instance, if I would, I can imagine what happens if I jump in front of my child who is biking, learning to bike. I'm behind a tree and I jump in front of it, and then I can imagine that she will fall off her bike and then she will be badly hurt, right? When I imagine that, I see very abstract things. I don't see pixel level sort of images floating by. So causality for me is interesting, but more in this sense, in a sense of, being able to unroll the world in, where I understand how concepts in the world, abstract concepts and objects in the world interact with each other. And so that I can imagine what the impact is from my actions in this world. So I can start to make plans. Now, causality is important in the sense that the physical laws of the world, but also social laws and all these kinds of things between these objects are causal, right? But it is this how do I say this? The way that we can predict these futures that makes us much more flexible and much more intelligent than the current sort of machine learning systems.
But if I may,
sorry, Robert. I think the time is it's okay. Hopefully, yeah. So I think our next question comes from Sarah. Yeah.
Okay, yeah, so actually I had another question, but then Max, you mentioned the social dilemma, and that really triggered me because you expressed some kind of positive appreciation for this documentary. But when I watched it, I was really frustrated. For me, it was this typical white tech bro apology of dudes that pretend that they didn't really realize what kind of technologies they were working on, completely kind of hide behind the algorithm and the data and whatsoever, and hardly then really take any responsibility for the power that they actually had in making these systems. And then in your presentation, or in response to one of the questions, you mentioned like how important it would be to collaborate or cooperate with the humanities and other fields. But I wonder really, like, how do you see this happening within your field, also maybe with your role as a professor, when still the general approach and the general attitude is, it's about the data, it's about the model. You also make better and bigger models. Like, for me, I don't see this really going forward in a positive sense for society. So how do you view that, or how do you see that actually developing?
So I didn't experience that movie as apologetic at all. Actually, I thought it was it was trying to uncover, all the bad things that have happened. But maybe I viewed it in a different way than you did, and sort of to expose all that. And I didn't. For instance, I thought Facebook was not getting with that movie in a way, right? So I saw it as a very negative for social media companies in the sense that they didn't do their job rather than apologetic. Yeah, so in terms of collaboration, I think so certain groups are, I see Senai Grahab was here, and yeah, so he's here too. So these groups are very natural bridges between the more technical and the more humanity sides. These labs that we created within ICAI, Civil Lab is clearly trying to bridge between these two communities. Also, our hybrid intelligence sort of grant, where we collaborate with lots of people also from the humanities, and we really look at problems like explainability, and how do systems between humans and machines work? How can they work together? So these are already two examples where I see this this sort of vision unfold. It doesn't have to be that everybody has to do this, right? That's the other side. You don't have to go into the extreme. I don't want one of my students who just worries about quantum field theory for deep learning to start thinking about, you know, responsible AI. That's not really relevant for his piece of research. This is a very large, wide spectrum of topics that we look at, and we just need to find places where these two communities naturally interact in a fruitful way. But I think it's already happening in my opinion.
Thank you.
Great. I have now Herman.
Hi. My question will also be about a link to causality. By the way, I agree your comments on the previous or answer on the previous question, but my question is a bit more specific. It is, so you said, right, causality is important, one of the important things for the future machine learning to integrate them. But on the other hand, you also said that you've been working on capturing symmetries, right, equivariance, and you've been working on these topics. So I wonder about any possible link between those two topics.
Yeah.
So one thing comes to my mind is, right, I mean, if you consider one road, I mean, some symmetries, for instance, more relevant, right? Some symmetries are not relevant, but some are relevant. If you consider a road, car might not go if it's perpendicular to it. Rather, it can go either forward or backward. For just an example about how some of these symmetries could still work in the real world. Is there any application or link do you see between these two?
So I can only give you a very vague answer. I'm pretty sure there is a very deep link. I have only started to probe this a little bit and thinking invariant concepts to causality. In my group and who's also at Qualcomm, who is very interested in this and who plans to work on this. So I believe there is a very interesting and deep connection between symmetries and causality, but I don't know precisely how it works, which makes it some of the more interesting research topics, of course. If you know how it works, you can just stop there right there. But I feel there is something very deep and interesting. Some people have probed this just a little bit, but I think there's a huge amount of other stuff that can be done. So myself, I've been working a little bit from a different perspective, which is to try to predict causality with a neural net. So for instance, you have time sequences, and let's say these are all balls which are moving together. This is work with Cindy Lowe and some people in Toronto, like Rich Semmel and David Madras. And so here what we do is we say, okay, just take these input sequences and then with a neural net predict how each object is causally related to each other object, and then instantiate those causal relationships, and then train a model that predict the future. And of course, you need a good model to predict the future, but also you need to have a good model to predict the causal relationships. So if you're getting better at predicting causal relationships, you're getting better at predicting the future. And so you can actually, in that way, figure out, you know, how objects interact with each other. So there's not quite symmetries in there yet, but you know, certainly we are working on it in the sense that if these causal relations are sort of maybe rotational symmetric, then you can certainly put them into that neural net. Yeah.
Thanks.
Thank you. And now, Natalie.
Yeah, thank you very much. Thank you also. Wait a minute, we have to
Big echo.
switch off the speaker. We're watching here actually with a couple of our team, and thank you so much for sharing your very scarce time with us. So this is super interesting. I would like to follow up a bit on the question of Sarah. you already mentioned, and very rightly so, that there's some, also at the UFA, some initiatives where social science research and technology research already meet, like in the Civil AI Lab, also in Humane AI. We see that also in the AI Coalition, but what we also see happening a lot is that those conversations are limited to certain labs or communities, and I would like to ask a bit further about the spillover effects of that, and maybe also where you see the limits of these conversations between SSR and technology. So say, for example, that humanities research would say that a particular application should not, what would be your response? Will you instruct your PhDs not to build it, or how else should we deal with these more responses from humanities, which might be more than just talking?
Well, I would not take it as an oracle and say, oh, the humanities has said I shouldn't work on it, I'm not going to work, I just stop everything. No, this would not be the type of interaction I would envision. But I would certainly, if there is like warning signs coming from other communities and there's good sort of reasoning, say, this might happen if you continue on this track or something like this, I would certainly engage in the discussion clearly and then draw my own conclusions. I mean, it's not like, right? It's not a one-way street, clearly. So I guess the way to facilitate this is to have a podium for these kinds of discussions. What else can you do in some sense, right? I mean, I very often engage in these kinds of discussions. And in fact, I'm also within ILLC, which is the European Lab for Learning and Intelligent Systems. We have groups who are like Nuria Oliver, maybe you know her, who is also in our board, who is working on topics. So we make sure that all these topics have a place also in the more technically driven part of AI. But yeah, so, and it has to grow, I guess, as well. I mean, there's clearly a huge push from the European Union that these are important things to think about. So I'm personally not so worried about whether this conversation is happening or not. But I guess since I have had two questions that are fairly strongly formulated, I think your perspective or your experience of this is quite different. Maybe that's a counter question.
Yes, it's a very good question, and let's say it's mixed. I've seen a lot of change in the past 2 years. That there was more, I think, willingness to listen on both sides and willingness to understand both points of view. I still see that, for example, the societal, ethical, legal aspects in the AI coalition are still very much limited to one work group, and all the other work groups very much go into doing technology innovation. So I think we are at the beginning of a process that you just described, and and that's also one of the reasons why you founded Humane AI, because we really much hope that this could be such a platform as you just described.
Yeah. So again, for me, it's also important to re-emphasize that not every AI is AI that needs to be, thought through in terms of its, potential, impact on society, negative impact on society. There is a lot of that AI that needs to have that discussion, but there's also a lot of AI that doesn't. Area, I don't think we need to engage everybody in this discussion, but I think it's particularly important to figure out which parts of AI will have potentially this negative impact on society, which is AI that has with decisions about human beings. That's the part of AI that we really need to think with humanities, but also with legal consultants, right? With people from the legal sort of department, and there's psychologists, people who do communication. All these types of groups need to come together for that part of AI.
Thank you. So we have one final question, which I quickly want to ask now. Nikos, do you want to ask that yourself, or do you want me to ask?
Yes, I can ask it. Thank you very much.
Good.
First, I would like to thank the organizers and Professor Welling for their time setting this up. Professor Welling, so especially in the hybrid AI, but I guess also on humane AI, there is this concept of people collaborating with AI systems, which we haven't seen any of that so far. And I see so many walls that will not help this, or in my imagination at least. So computers currently only work in their own very specific environment. There is no interaction between them. So I would like to ask, what is your opinion how we could introduce a human in the loop of an AI system, or what would be the first steps towards something like that?
Yes, it's a great question, but I disagree a little bit with the fact that we haven't seen, systems that interact with humans. I think, in fact, most systems interact with humans. I mean, if you go type in a question in Google, you interact with an AI, right? If you sit in a self-driving car or in a car that is somewhat intelligent, you interact with an AI system. So if you look on your phone, you interact with an AI system. So the whole field of HCI, right, human-computer interfaces, deals with how do humans most effectively interact with computer systems and with increasingly with AI systems. So I think it is a whole field, and I think there is, but still you can ask the question, how do you do it more effectively? And this hybrid intelligence is clearly, one part of that grant is clearly about how to do this more effectively. Now you can think about, augmented reality to make at least the interface smoother. But also you need systems that can understand the context of a human. So in other words, what is the intention of the human when the human asks for help or asks a question, right? I mean, you can interpret this in many ways. It's not just that you need to translate, the speech that's coming at you into in a nice sounding sentence. You have to understand, in some sense, feel what the human feels and what the intention of the human is in order to understand what to do and how to really assist and help a person. Now, I think that requires a much higher level of intelligence. It requires much more context. Like maybe a knowledge graph where a lot of information about how the world really works, right, is encoded. So I guess there's a lot of work to be done in that sense, but I really think it's happening, and there's a lot of people working on that as well.
Thank you, Nikos. That was really the perfect final question to our Humane AI event. And I think, Claes, I hope you agree that that went very well. No, Aybüke? So I thought we can be very proud of ourselves. And I think that's, of course, largely due to our wonderful speaker, Max Spelling. So one big clap for Max. And then, of course, also to the audience who have asked wonderful questions. So one clap for the audience too. So thank you very much. And we hope to see you all again at future events. And I look forward to the further communications.
Thank you very much, Tobias, for having me. Okay.
Thanks,
Bye-bye.
Max. Bye.
Thanks. Bye.